Okay, now that we've covered brain development, I want to move on to talk a little bit about what we actually know about babies. So we've said babies are born, but what is it they actually like to do? What do they look at? What do we know about babies? That's what we're going to talk about next. And your book talks a lot about how one of the first things we can do is look at what babies sense. If you think about the senses that we have, things like vision, hearing, what is it that babies actually sense? And before we can answer that question, we have to talk a little bit about how in the world we even ask that question. We can't simply go up to a baby and say, "Hey baby, what is it that you know? What do you sense? What do you see?" So there are a couple different methods that I want to talk about really briefly to look at what is it that babies actually sense about the world. What kinds of things do they know? One of the methods that we're going to talk about is observation. This is just as easy as it sounds. Basically, we observe and see what babies do and how they react. One is called preference studies. In this case, we basically give babies a choice. We ask them to choose something to give us an idea for what they like or what they notice. The third thing is called habituation, and we're going to talk a lot about that, especially in the next part of the course when we look at babies and what they know about number. Habituation is something that we can do to rats. I can habituate you. There's a lot that we can do in terms of habituation, so I'm going to explain what that term means and how we use it. And then finally, we can look at how different aspects of technology have really helped. So looking at how babies develop using technology. To start off, I want to talk about observation. And basically, this is really simple. You have this baby, and what you do is you introduce something. You introduce a stimulus. A stimulus. So something like a sound, a light, a vibration. If I were to clap my hands right now, that would be a stimulus. So we introduce something, and then we measure the response that the infant would give, and if any. So basically, this tells us, did the baby notice anything? So for instance, we could introduce a stimulus. Let's say that we have a baby come into the lab and we show them a light. We can measure something like heart rate. What kind of heart rate? Does their heart rate change? Do they blink? Do they turn their heads? Do they show a startle reflex? Do they change their sucking rate? Right? Basically, we want to observe to see what they do. So in this case, we're just introducing a stimulus and measuring a response. If babies don't notice anything, then we wouldn't see any response. If I were to have a baby come into the lab, I clap my hands really loud and they don't notice anything, it means that they didn't register that stimulus. They're not having any response. So we can look at things like heart rate, respiration rate, blink, head turn, startle, sucking, any of these kinds of reactions that a baby may have, we can use that to tell us what they're thinking or what they know. So this is kind of a really simple way to look at what babies can tell us. What can they tell us about what they know and what they see? Do they hear anything? For instance, if we wanted to measure whether or not babies were sensitive to different smells, we could have them come into a lab and we could present them with a certain smell and see what kind of response they would have, if any. If a baby doesn't respond at all, then that tells us that maybe they didn't notice it, that they weren't able to pick up on that, they weren't sensitive to that kind of a stimulus. So this gives us a really basic response of what is it that babies can pick up on? What is it that they are sensitive to? So observation is one method. Another method is a preference study. So now we have that same baby, and let's just say we were doing research for Sesame Street. And what I wanted to know is whether or not babies prefer one character over another. So I'd have, say, this baby come into the lab, and now I put them in between two computer screens. On one computer screen I have Big Bird, on another computer screen I have Elmo. And then basically all I do is look at which one of these figures this baby prefers to look at. So let's say this baby prefers Elmo. That tells us that A, the babies can tell the difference between those two characters, but also that they have a preference. So we can use this to figure out what is it that babies prefer? What do they like to look at? So we can use a preference study. Another kind of method we can use is habituation. Now this is something that's pretty simple, which is basically you want to habituate or bore. A good way to think about habituation is boring. You habituate or you bore a baby to something. So hey, let's say that we now want to show the baby Big Bird. We show baby Big Bird. Baby says, oh, this is exciting. I want to look at Big Bird. There's no other Elmo, it's just Big Bird. Big Bird's on the screen, baby looks. You show them Big Bird over and over and over and over again until the baby gets bored. We know that babies get bored, A, if they fuss, but mostly if they look away. It's just like you. If you see a new movie, you tend to really be engaged in it. You watch it really closely. Whereas if you've seen that same movie 30 times, you're a little bit more bored. You might look away, you might take a phone call, you might text more frequently, right? You're bored. So you're bored of it, you're paying less attention. Babies do that exact same thing. So what we do is we then bore a baby to something, might show them that again, but now we show them something new. If babies can tell the difference between these two things, they should react. How do they react? By looking a lot longer. Now let's go back to the example of you seeing a movie that you've seen a million times before. Now, you would probably react differently if now there's a new scene in that movie, right? If now you got the secret footage that's on the DVD, you're gonna really look a lot more at that because it's something new. You've told the difference. You've dishabituated. So you habituate to something, you basically get bored with it. When you dishabituate, you get unbored. So you will look a lot longer. And then if I show you that same boring old thing again, you're still bored, right? So using habituation, we can not only tell that babies can kind of get bored with something, but that they can tell the difference when something new occurs. And we're going to see this a lot when we look at how babies learn about number. Another thing we can do is use technology to help us. One of these technologies is called event-related potential, which basically measures the electrical activity in the brain. I actually did studies like this when I was an undergraduate with adults, but the same kind of thing can be used with infants. So I want to show you an example of that.
Pint, rate, dog, cup, shoe, book, pint, rate, dog, comb, dog, walk, milk, book, wood.
One of the things that we found so far is that when children who are between 13 and 17 months of age are listening to words that they understand versus words that they don't understand, the words that they understand have more activity on both the left and the right side of the brain. When children are 20 months of age or when they've undergone a big vocabulary spurt, they tend to be, those differences are just in temporal parietal regions of the left hemisphere. The language areas in adults are the only areas showing those differences. So there's a big change in the organization of the brain. One of the things we're interested in is whether that's related to just age and the maturation of the brain, or whether it's related to experience with language. So we've studied children who are late talkers, who are older, 20 months and 28 months, and found that same shift from both sides to the left side at a later point in development, which suggests that it's vocabulary science that's driving that. We've also looked at children who are learning two languages at the same time and found different patterns of organization for the language. They have more words in than the other words. So it can't really be brain maturation driving the changes because it's the same child who has two languages, it's the same brain. Now we're studying children like Molly who are younger, who have undergone this big vocabulary spurt at a younger age, to look and see if we can find those changes earlier on in development.
Okay, so that video was a little bit hard to get, but basically what I want you to know is that there's other ways for us to look at what babies can tell, what they know, and how their brains are developing. Event-related potential, if you remember, they basically kind of looked at those squiggly lines, almost like a heart monitor, but that was really measuring electrical activity in the brain. And what they were looking for were spikes or differences that would happen, say if a baby heard words that they knew versus when they didn't, words that they didn't know. And if you recall, they also, that video showed about cerebral specialization, basically that you see that certain hemispheres of the brain are a little bit more tuned than others. So the left side of your brain is more tuned for language, for instance. Basically, again, I just want you to see that there's different methods that we can use to monitor what kids actually know. Again, so here are the four methods that we see: observation, preference studies, habituation, and different kinds of technology. And I'm going to show you examples of this throughout the entire rest of the semester, what we can tell based off of using these methods. So I'm going to stop here, and then for the final part of this lecture, I'm going to talk about sensory systems for kids.